A-level mechanics, statics problems, resolving forces. When solving problems involving forces in 2 or 3 dimensions, one of the most useful tools is being able to resolve vectors. If we have a vector in 2 or 3 dimensions, it can be resolved into 2 or 3 components, usually at right angles to each other. For example, suppose we have a force acting on a body as in the diagram. The force can be regarded as 2 components, one acting horizontally, trying to move it across, and one acting vertically, trying to lift it up. If an object in equilibrium has several forces acting on it, then the horizontal components of the forces must balance out, and the vertical components must also balance out. If we look at the diagram, we see a body of mass m suspended by 2 wires. One has tension T and one has tension S. Gravity acts vertically downwards with a magnitude of mg, and we can resolve T into a horizontal component and a vertical component. Similarly, we can resolve S into a horizontal component and a vertical component. Then, the horizontal components of all the forces must balance, and the vertical components of all the forces must balance. So in this case we have TH is equal to SH, and TV plus SV is equal to mg. If we find the component of a force in a particular direction, we call this resolving the force in that direction. We can resolve in other directions apart from horizontally and vertically. For example, consider an object on an inclined plane. In this case, we may wish to resolve up the plane and at right angles to the plane. The key thing to remember when resolving a force is: first choose the direction you want to resolve in. Then the component in that direction is the magnitude of the force times the cosine of the angle between the force and the chosen direction. So in this example, the component of F in the chosen direction is F cosine theta. Always choose carefully the directions you want to resolve in. Let's look at an example. Example 1. A mass of 5 kg is suspended from a ceiling by 2 cables, one at 60 degrees to the horizontal and one at 30 degrees to the horizontal. Find the tension in each cable. Well, to solve this, as in any mechanics problem, always draw a diagram first. Then mark in the forces. We have a tension in the cable at 60 degrees that we can call S, and we have a tension in the cable at 30 degrees that we can call T, and we have a force of 5g vertically downwards due to gravity. Now, one way to tackle this problem would be to resolve horizontally and vertically. This gives us angles between S, T and the horizontal of 60 degrees and 30 degrees. So, S cosine 60 equals T cosine 30. When we resolve, it's always the force times the cosine of the angle between the force and the direction we want. We can call that equation 1. And if we resolve vertically, the angle between S and the vertical is 30, and the angle between T and the vertical is 60 degrees. So we get S cosine 30 plus T cosine 60 is 5g. We can call that equation 2. Now the cosine of 60 degrees is a half. So in 1 we've got S times a half equals T cos 30. And if we double both sides, we get S equals 2T cos 30. And if we substitute that into equation 2, that gives us 2T cos squared 30 plus T cos 60 equals 5g. But cos 30 is root 3 over 2, so cos squared 30 is 3 over 4. So this gives us 2t times 3 over 4 plus t times a half equals 5g. That's 3 over 2t plus a half t equals 5g, or just 2t equals 5g. So t is 5g over 2, which is 24.5 newtons. Now we've also got S is equal to 2t cos 30. So S is equal to 49 cos 30. And if we work that out on a calculator, it comes out that S is 42.4352. So rounding it off, we've got an answer. T is 24.5 newtons and S is 42.4 newtons. Now all of this could have been done much more easily if we'd resolved along S and along T. So if we resolve along the direction of S, we find T is at right angles to it and so it doesn't come into the equation. And the angle between S and the vertical is 30 degrees. So we get S is equal to 5g cos 30. And typing that in a calculator, we get S is 42.4 newtons. If we resolve along T, the angle between the vertical and T is 60 degrees. So T is equal to 5g cos 60, which works out T is 24.5 newtons. So we get the answer S is 42.4 newtons and T is 24.5 newtons, which is the same answer as we had before, but we got it much more quickly. So we can see the value of selecting the resolving directions carefully. Let's look at another example, example 2. A body of mass 4 kg rests on a slope which makes an angle theta with the horizontal. The normal reaction is 35.5 newtons. In part 1, we're asked to find the value of theta. Well, to solve this, we're going to start by resolving perpendicularly to the slope. Now we can see the angle between the direction we've chosen and the vertical is theta. So we have 4g cosine theta is equal to 35.5. If we divide both sides by 4g, we get cosine of theta is 35.5 over 4 times 9.8. So theta is the inverse cosine of 35.5 over 39.2, which works out to be 25.09. So we get our answer, theta is 25.1 degrees. Now in part 2, we're asked to find the frictional force. To find the frictional force, we need to resolve up the plane. Now the angle between the plane and the vertical is 90 minus theta. So that tells us F up the plane is equal to 4g cosine 90 minus theta down the plane. But cosine 90 minus theta is sine of theta. So F is equal to 4g sine theta. So F is 4 times 9.8 times the sine of 25.09, which is 16.62. So the frictional force is 16.6 newtons. Note, it's always worth remembering that the cosine of 90 minus theta is the same as sine of theta, and sine of 90 minus theta is equal to cosine of theta. When resolving forces, it's also important to remember the resolved component is the force times the cosine of the angle between the force and the chosen direction. Sometimes this angle is not given, but the angle between the force and the perpendicular is given. In that case, use cosine of 90 minus theta is equal to sine of theta. Let's have a look at another example, example 3. A body of mass 3 kg rests on a table and a force of 15 newtons acts on it at an angle of alpha to the horizontal. The normal reaction is 20 newtons and there is a frictional force F. In part 1, we're asked to find alpha. Well, to solve this, to start with, we'll resolve vertically. Now the angle between the force of 15 newtons and the chosen direction, which is vertical, is 90 degrees minus alpha. So 20 plus 15 cosine 90 minus alpha is equal to 3g, or 20 plus 15 sine alpha is 29.4. So 15 sine alpha is 29.4 minus 20, or sine alpha is 29.4 minus 20 over 15, which means alpha is the inverse sine of 9.4 over 15, which when we type it in a calculator gives alpha is 38.80 degrees. So our answer is alpha is 38.8 degrees. Now, if we resolve horizontally, the angle between 15 newtons and the horizontal is alpha. So F equals 15 cosine alpha. Now we know that alpha is 38.80 degrees, so typing that in a calculator we get F is 11.69, so our answer is the frictional force F is 11.7 newtons. In example 4, we have an object of mass 22 kilograms resting on a plane at an angle of 35 degrees to the horizontal. The coefficient of friction is 0.2. There is a force at an angle of 23 degrees to the plane, just preventing the object from slipping down. Find the magnitude of the force P. Well, to solve this, we need to resolve up the plane. Now, the angle between the vertical and the plane is 55 degrees. And because the object is just about to slip down, the frictional force is up the plane. So P cos 23 plus F is equal to 22g cos 55, which means F is equal to 22g cos 55 minus P cos 23. Now if we resolve perpendicularly to the plane, we have the angle between the perpendicular and the vertical is 35 degrees. And also the angle between P and the perpendicular is 67 degrees. And so that gives us N plus P cos 67 degrees is equal to 22g cos 35 degrees. So N is equal to 22g cos 35 degrees minus P cos 67 degrees. But because the object is on the point of slipping down the plane, we have F is equal to mu n. In other words, F is equal to 0.2 n. Now, if we substitute 1 and 2 in 3, we've got F is 22g cosine 55 degrees minus P cosine 23 degrees equals 0.2 times n, which is 22g cos 35 minus P cos 67 degrees. Well, we can simply expand the bracket with 0.2 outside, and then we can get all the terms with P onto one side and the remaining terms on the other side. And that gives us 22g cos 55 minus 4.4g cos 35 equals P cos 23 minus 0.2p cos 67. And we can factorise the right-hand side by taking P outside the bracket. And then finally we can divide by the bracket that P is multiplied by to give P is equal to 22 times 9.8 cos 55 minus 4.4 times 9.8 cos 35, all divided by cos 23 minus 0.2 cos 67, which when we type it into a calculator gives the answer 104.87. And so we have the value of P is 104.8 newtons. Let's have a look at one more example, example 5. A mass of 3 kg is suspended from 2 strings attached to a beam at angles 20 degrees and 40 degrees to the horizontal, as in the diagram. In part 1, we're asked to mark in the tensions in the strings at the point they join each other. Well, in the first string at 20 degrees to the horizontal, we can draw in a force marked S. In the second string at an angle 40 degrees to the horizontal, we can draw in a tension T, and the string attached to the weight will have a tension 3G. Now in part 2, we're asked to calculate the tensions in the upper 2 strings. Well, one way to do it would be to resolve horizontally and vertically. If we resolved horizontally, the angles between the horizontal and the two strings are 20 degrees and 40 degrees. So S cosine 20 equals T cosine 40. Or S is equal to T cosine 40 over cosine 20. If we resolve vertically, the angles between the strings are 70 degrees and 50 degrees. So in the upwards direction, we've got S cosine 70 plus T cosine 50, and that's equal to 3G, 3 times 9.8. So if we substitute equation 1 into equation 2, we get T cos 40 over cos 20 times the cosine of 70 plus T cosine 50 is equal to 29.4. Now we can take T out as a factor of the first two terms. So that gives us, when we work it out, 0.9216T is equal to 29.4, or T is 29.4 over 0.9216, which is 31.901. Now we've got S is equal to T, which is 31.901, times the cosine of 40 over the cosine of 20, which equals 26.006. So S is equal to 26.0 newtons and T is equal to 31.9 newtons. Alternatively, we could resolve perpendicularly to S and to T. Now, if we draw a line perpendicular to S, we can calculate the angles and resolve. We get that T makes an angle of 30 degrees with it, and gravity makes an angle of 20 degrees with it. So T cos 30 equals 3G cos 20. So T is equal to 29.4 times cos 20 over cosine of 30, which is 31.901. And resolving perpendicularly to T, we have the angle between S and the direction is 30 degrees, and the angle between the vertical and the direction is 40 degrees. So we have S cosine 30 equals 3G cosine 40. So S is 29.4 times cosine of 40 all over cosine of 30, which is 26.006. So our answer is S is 26.0 newtons and T is 31.9 newtons, exactly the same as before, but this is a quicker method.